Hi, I'm Jim Balhoff, um, a researcher in the Data Science and Analytics group at the Renaissance Computing Institute at UNC Chapel Hill. I'm going to go through a few of the technical features of the FRINK project, part of the Proto-OKN. So FRINK stands for Fabric Integrating Network Knowledge, and it's part of the technical backbone of the Proto-OKN project. And our focus is on making the different knowledge graphs provided by the contributing groups that are covering a number of different domains, interoperable and queryable together. So a few things I'm going to cover in this presentation are graph technology, our ingest pipeline, query APIs, and then our Proto-OKN registry. So FRINK employs a common graph technology in order to bring together all the different knowledge graphs in the OKN. And so what we've settled on is RDF. So RDF is the Resource Description Framework. And there's a few reasons why we've settled on RDF versus some other graph database technologies that are available. So for one thing, RDF is a W3C standard, so it's a web standard that's publicly available. It's also got a standardized query language called Sparkle. And so because it's oriented towards the web, RDF is kind of proven technology for distributed knowledge graph integration. So it's designed with many web-based features in mind. And so these are things like global identifiers for nodes, use of standardized vocabularies, and also providing web-centric query protocols. So you can issue knowledge graph queries over the web, submit knowledge graphs over the web. So it works quite well for distributed graphs. And so unlike some other available knowledge graph technologies, there's standard syntax for sharing graphs. So it's easy to represent a knowledge graph in a file which can be shared. You can easily merge knowledge graphs together. And also you can apply the query language not just to a database, but also just to a simple file. So it has a lot of conveniences in that regard. So FRINK provides something we call the landing zone in order to host the knowledge graphs developed by the OKN Theme 1 groups. This is based on some software called LakeFS, which is a Git-like storage and versioning for uploaded knowledge graphs. So you might be familiar with Git, which is a version control system. And so we use this LakeFS kind of as a version control for knowledge graphs. It also provides some hooks for executing an ingest pipeline whenever a new version of a graph is uploaded. And so this pipeline handles a few different tasks. So for one thing, it, if necessary, converts the data to RDF. So some of the groups use a knowledge graph technology called Neo4j. And so we provide a way to map from Neo4j into RDF and kind of do that repeatedly whenever they upload a new Neo4j database. It may perform some additional transformations, so doing some geometry computations for some geographical features. And there's a system called S2, which some of the groups make use of to describe locations of features. We compute node embeddings on the uploaded graphs, and et cetera. And so next, the pipeline converts the graph to HTT, which is a kind of queryable storage, which I'll say more about. And then it runs some graph characterization analyses. So these are available to be reviewed by the submitting team, before the new version of that graph is released to the network. And then, once all these parts of the pipeline are done, then the query APIs are redeployed, allowing access to the new data. So for each of the graphs, it's stored as an HTT file in our system. So HTT is just a very convenient file format in that it's compact, but also it's immediately queryable. It doesn't need to be decompressed before reading. So we take advantage of this by using it as a backend for some of our services, and also as a convenient way to download a graph and execute queries over it. And so for each Theme 1 graph, we provide a Sparkle endpoint and TPF endpoint. So Sparkle is the standard graph query language for RDF. And TPF is another query language which is simplified, stands for triple pattern fragments. It allows you just to query a single triple pattern and page through all the data. And so currently, across a number of different graphs, I think about 20 different Theme 1 graphs now. There's about 50 billion triples total that are being managed by FRINK. So in addition to these query services for each uploaded graph, we provide a unified query service which allows users to execute a query, looking at all the information from all the graphs at once. And so this ability to query and integrate data from across multiple distributed knowledge graphs is known as query federation. And so we make use of an open source system called Communica to provide federated queries over multiple query endpoints at once. So this could be any number of the Sparkle endpoints or TPF endpoints for each of the graphs, as well as external query endpoints that are not part of OKN. Now, while query federation can be quite powerful and convenient, it also is a little slower than when all the data are integrated into a single database. So to provide a higher query performance, we're using an open source triple store called Clever. So a triple store is a database for RDF. And we're currently integrating all of the OKN graphs into that single database for a high performance query endpoint. So FRINK's Sparkle endpoints can be explored in our Communica-based query interface, which is linked from the FRINK homepage. So these Sparkle endpoints can be accessed directly just to directly explore the raw data, but they also support data access from Spider, which is our counterpart infrastructure project, which provides more of a natural language query interface. And in addition, the Sparkle endpoints can be built on by individual Theme 1 groups to create custom project UIs. So the last part of FRINK that I'm going to touch on is the OKN registry. So the registry is a GitHub-based site where we manage some of the graph metadata. And so we're encouraging contributors to OKN to directly kind of take ownership of information about their graphs and provide edits via pull requests at GitHub. So the pull request is just a public way of contributing changes to an open source project and that can be accepted by the maintainers. And so the registry is used to generate the FRINK website, which lists all of the Theme 1 graphs, but it also is rendered as a machine readable file, which we use in some downstream tools, such as the FRINK query page, where you can select which graphs to query. The registry also links to the Sparkle endpoints for each graph, and then it links out to the FRINK pipeline outputs, such as graph characterizations. And so these include some automatically extracted schemas, so which classes are available in the graph and what relationships they have to other classes in that data set, as well as counts of class occurrences or relations. So I'm going to finish with a few future directions for FRINK, things that we're currently working on. So one of these is improving our graph characterizations to better describe what's in each graph. And then to build on that, we're creating something called the OKN map. And so this helps users define what are the points of overlap among OKN graphs. What vocabularies do they have in common? What kinds of entities are shared among them? And so something we're adding to our ingest pipeline is computation of node embeddings. So these provide a means to find which nodes in the knowledge graphs are similar, even though they might use different identifiers in different graphs. So one graph might have an identifier for the University of North Carolina. Another graph might also represent the university, but using some other identifier system. But there might be textual information that's the same, such as the label or its relationships to other kinds of nodes. And lastly, we'll be developing tighter integration with natural language query interfaces provided by the Spider project. So thank you for listening.